Hi, the name of this Blender video tutorial is Pivot Constraint and TrackTo Constraint. One of Blender's relationship constraints is named Pivot. The pivot constraint allows one object to use an object's origin of another object as its pivot point. One of Blender's tracking constraints is named TrackTo. The TrackTo constraint allows the positive x, y, or z axis of one object to point to the negative or positive x, y, and z axis of another object. We have looked at the TrackTo constraint in an earlier video tutorial named Camera Constraint, where we used the TrackTo constraint to force the camera object to point to another object. I will expand upon this tracking feature in this video tutorial. To demonstrate the pivot and TrackTo constraints, I've modeled in my Blender scene a very simple dump truck. The dump truck consists of four wheel objects, a cab object, a dump box object, and a chassis object. The dump box is connected to the chassis by an object named dump box pin. The dump box, when opened, rotates around this dump box pin object. I'll go to wireframe mode so you can see the mechanism that forces the dump box to rotate open and rotate close. This consists of four objects. First, the piston object. Next, the piston rod object. The piston rod extends out of and back into the piston object. The piston object is connected to the chassis object via the piston pin. The piston rod object is connected, or rather will be connected, to the dump box object via the piston rod pin. Currently, the piston rod assembly in front view is modeled along the global X, Y, and Z axis and is unattached to the dump box. I did this because the constraining process is more understandable when described along global X, Y, and Z axes rather than along local X, Y, and Z axes, which is what would be required if the assembly were connected from the start. To begin the constraining process, we'll look at the pivot point for the dump box object. I want the dump box to rotate around the dump box pin. Now I could move the dump box's origin point to the same point as the dump box pin, making that the point of rotation. But another way to do this is to use the pivot constraint. Before I added the pivot constraint, I'll select the dump box pin object and then press Ctrl A and apply the existing rotation of the dump box pin. This sets the rotation settings for the object to X, Y, and Z equals 0, but it retains or applies any existing rotation. I will also select the dump box object and press Ctrl A and apply the rotation. Generally, when using Blender constraints that are connected somehow to an object's rotation, it's important to apply the existing rotation before constraining it, or constraining another object's rotation to it. I'll select the dump box object, go to the constraint panel, and add a pivot constraint. In the pivot target box, I'll select the dump box pin object. In the pivot when box, I'll select always. I actually only need it for the Y rotation in this example, but in practice, the dump truck may be at any angle in a scene. Now if I select the dump box object and press the R key, rotate, the rotation of the dump box object is around the dump box pin Y-axis. To demonstrate the piston rod assembly constraints, I'll hide some of the scene objects so that we can have a better view. I'll hide the cab, the chassis, the dump box pin, and the four wheel objects. We are now left with the piston rod, and their two adjoining pins. The first thing we need to do is to place the object origin point for the piston in the same X, Y, and Z location as the origin point for the piston pin. We then need to place the piston rod origin point in the same X, Y, and Z location as the origin point for the piston rod pin. I'll select the piston pin object and press Shift-S, snap, and snap my 3D cursor to the selected. This places my 3D cursor at the origin point for the piston pin. I'll then select the piston object and press on the Origin button in the left tool panel and select Origin to 3D Cursor. Now the origin point for the piston object is at the same X, Y, and Z location as the origin point for the piston pin object. I'll now select the piston pin object and for the moment hide it. I'll then select the piston rod pin object. I'll press Shift-S, snap, and snap my 3D cursor to the selected. This places my 3D cursor at the origin point for the piston rod pin. I'll then select the piston rod object and press on the Origin button in the left tool panel and select Origin to 3D Cursor. Now the origin point for the piston rod object is at the same X, Y, and Z location as the origin point for the piston rod pin object. I'll now select the piston rod pin object and for the moment hide it. I next need to add two empty objects to the assembly that will act as control empties for the piston assembly. One needs to be located in the object origin for the piston, and the other needs to be located in the object origin for the piston rod object. I'll select the piston object and press Shift-S, snap, and snap my 3D cursor to the selected. This places my 3D cursor at the origin point for the piston object. I'll then press Shift-A and add an empty object. I will name this object Empty Bottom. I'll then select the piston rod object and press Shift-S, snap, and snap my 3D cursor to the selected. This places my 3D cursor at the origin point for the piston rod object. I'll then press Shift-A and add an empty object. I'll name this empty Top. I now have an empty object located at the origin points of the piston and the piston rod objects. Before I can add a constraint to the piston or piston rod assembly, I'll select the piston object and press Ctrl-A and apply the existing rotation. I'll select the piston rod object and do the same. The two empty objects, since they have just been created, already have their X, Y, and Z rotation set to 0. Now before I add the constraints, it might be instructive to look a bit closer at the construction of the piston and the piston rod objects. I'll select the piston rod object, turn off my 3D transform widget, and go to the Object Data panel, and in the Display panel, checkmark Display Axis. Notice that the Z-axis of the piston rod object is pointing upwards, and that the negative X-axis is pointing toward the piston object. I'll select the piston object and turn on the axis display. Note here that the Z-axis of the piston is pointing upwards, and the positive X-axis is pointing toward the piston rod object. It is quite easy when modeling a piston or piston rod type objects to end up with a negative axis pointing upward. The TrackTo constraint, in order to work properly, requires that the object have a positive axis pointing upward. We'll see this later when we add the TrackTo constraint. I'll turn off the axis display for both the piston and the piston rod objects. And I'll turn back on my 3D transform widget. I'll then select the piston rod object and go to the constraint panel and add a TrackTo constraint. In the target box, I'll select the piston object. As we saw when the axis was displayed, I want the negative X-axis of the piston rod to point to the piston object origin. And I want the Z-axis of the piston rod object to point upward. I'll then select the piston object and go to the constraint panel and add a TrackTo constraint. In the target box, I'll select the piston rod object. As we saw when the axis was displayed, I want the positive x-axis of the piston to point to the piston rod object origin. And I want the z-axis of the piston object to point upward. Next, I will select the piston rod object, hold down my Shift key, and add the empty top object to the selection. I'll then press Ctrl P and make the empty top object a parent to the piston rod object. Next, I'll select the piston object, hold down my Shift key, and add the empty bottom object to the selection. I'll then press Ctrl P and make the empty bottom object a parent to the piston object. The empty top object now controls the piston rod object, and wherever the empty top object moves, the piston rod object follows, all the time pointing or tracking to the piston object origin. The object now controls the piston object, and wherever the empty bottom object moves, the piston object follows, all the time pointing or tracking to the piston rod object origin. I'll now unhide the chassis and the piston pin objects. I'll select the piston pin object, hold down my Shift key, and add the empty bottom object, and then add the chassis object. I'll press Ctrl P and make the chassis object a parent to the piston pin and the empty bottom objects. This secures the objects to the chassis. I'll then unhide the dump box object and the piston pin object. I will select the empty top object, and since it controls the piston rod object, move the piston rod object so it is aligned to the dump box connection point. I'll then select the piston rod pin and also move it to the same connection point. I'll then select the piston rod pin, hold down my Shift key, and add the empty top object to the selection, and then select the dump box object. I'll then press Ctrl P and make the dump box object a parent to the piston rod pin and the empty top objects. If I now select the dump box object, press the R key and rotate it, the piston rod assembly responds logically. I will unhide all of the objects. And I'll go to solid shading mode. I'll set the animation length to 200 frames. On frame number 1, I'll select the dump box object and press the I key and add a rotation keyframe. I'll go to frame number 100, and with the dump box object selected, I'll press the R key, followed by 45, and then enter. This will rotate the dump box 45 degrees. On frame 100, I'll add a rotation keyframe to the dump box object. I'll then go to frame 200. With the dump box object selected, I'll press the R key, followed by -45, and then enter. This will rotate the dump box back to its original position. On frame 200, I'll add a rotation keyframe to the dump box object. I'll then go back to frame number 1 and play the animation. The dump box rotates on the dump box pin origin, and the piston rod assembly operates as it logically would in real life.